Hello, everyone, and welcome to tutorial 1130. Today, we're going to be talking about the SUSE Edge and ZeroTrust Edge connectivity with the OpenZiti project. I'm Thomas McGonigal, and my friend and colleague Philip Griffiths are here today to talk to you about the OpenZiti project and using it at the edge. Today, we're going to be going over, we're going to be introducing ourselves. We're going to be talking about our origin story. We're going to be talking about what ZeroTrust is, what an overlay network is, what SL Micro is, and what the role of OpenZiti and NetFoundry in this solution and in this tutorial. And we're going to be doing a demo as part of this presentation today. I'm Thomas McGonigal. I'm a solutions architect at SUSE. If you go to my LinkedIn, you'll see I have a streamcast called KD's Coach. That's supposed to be Kubernetes Coach. And Coach is spelled with a K, of course. And it's all about Kubernetes and coaching. And Philip has been a guest of mine on LinkedIn, and it's available on my LinkedIn profile. You can see Philip right up at the top. And it's just a pleasure to be here today. And we're going to be getting into why we're so interested in zero trust as part of this introduction today. And Philip is going to be talking about it for him as well. But when I first heard about zero trust, I had this like gestalt, which is, if anyone's not familiar with that word, it's when the private investigator has this like epiphany of who the culprit was, right? And so it's like this like this moment in time where you're just like, oh my God, this is going to be so big, this is going to be so powerful and so important. And so I had a gestalt when I first heard about zero trust, and then Philip and I will be kind of keeping this conversational today, but we'll be talking about how we kind of connected on zero trust, and he works specifically with NetFoundry, the makers of OpenZiti, and he'll be talking about himself and in his origin story and our origin story, and we'll be talking about that shortly. Philip, would you mind introducing yourself, please?
Yes, pleasure to meet everyone. So, Philip Griffiths, yeah, as it says, I look after strategic sales for NetFoundry. And myself and Tom have been speaking on off for almost 2 years now. I think it comes down to our joint passion around zero trust, which we'll cover on the origin story. But specifically for me, kind of why I really got interested in the area was prior to this role many years ago. I was working in a, would you believe actually, with the topic, an IoT practice. And one of the biggest problems that we saw of pilots not going to production was a lack of pilots and systems not being designed to deliver non-functional requirements, which it's not an issue when you're doing a pilot, but it's a massive issue as you go to production. And so as I joined this new role, I knew very little about networking, but as I learned more about it, I remember reading the O'Reilly book on zero trust and just thinking, this is exactly how it should be done. The lack of zero trust in our current setup is why we have so many attacks. And for me, open source is a massive aspect of that. In fact, just this morning, I was reading a recent Cyberscoop event where the Cheryl Pascoe, who is the NIST director for the National Cybersecurity Center of Excellence, was talking around how they were doing a project on zero trust, and all the vendors were like, yeah, we can integrate with one another. And then it turned out none of them could integrate with one another, and they needed to move to a more of a standards-based approach. And in the same talk, Paul Selby, CISA for the Department of Energy, he was talking around how utilities have lots of legacy environments, lots of technical debt, and they need to work with the vendor community to help solve it, because utilities themselves cannot just solve the problem. And to me, this is why we have open source. This is why organizations like SUSE and Linux and NetFoundry and OpenZiti exist, to make solutions that solve problems that become the de facto standard. So when me and Tom were talking and he brought up this topic, I thought I would love to be involved. This is, to me, such an interesting topic.
Oh, thank you, Philip. That's a wonderful introduction. Advance the slide. I did mention that we have an origin story, and it really starts with the Executive Order EO 14028, And this is the president's executive order on cybersecurity, achieving zero trust and strong MFA. And it's pretty terse reading. It is an executive order, but to cut to the bottom line, the President Biden in 2021, May 21st, 2021, signed this executive order, and it required zero trust in all government computing, right? And it was very pervasive, and it was really kind of a big deal when it came out. And I said, oh my gosh, this is going to be an enormous market. It's going to be enormous projects. It's going to be really exciting. And so, so I think later on we define what zero trust is, but I think it's important just to discuss the core concepts and the key principles, if you will. And the key principles are to assume breach, assume that you've been breached, right? Provide least privilege access. And these are the key principles once again, and continuously verify, right? And so authentication is a major part of zero trust, and it's one of the kind of more interesting parts for me. You have to always be authenticating, whether it's a device or whether it's an application, right? These are you can use zero trust with at the application layer with the SDKs in OpenZiti, and leveraging this authentication and this least privilege access and this assuming breach provides a much more consistent and secure environment for your computational resources. And so I'm just going to pause and just defer to Philip. Were you aware of the executive order when it came out? Were you at NetFoundry when it
I
came out?
was at NetFoundry, so when we saw it, we were. I remember going to events pre this and saying, "Oh, have you ever heard of zero trust?" And people were like, "What the heck is zero trust?" But
Right.
once this came out, it'd be like, even Biden's heard of zero trust. Everyone's heard of zero trust. Now every product zero trust. So there was very much a before and after. Um, but then again, I think it really widened people's understanding, but it led as well to other people looking at how can I take those principles, how can I apply them, which led into why we initially started talking, and the I don't want to call it a paper, the principles that you wrote up that I came across.
That's absolutely right. Um, Yeah, it's just it's a big deal. I guess that's really what we're trying to articulate at this point in the presentation, right? Zero trust is a big deal. The federal government has mandated it. Zero trust is just critical for workloads, and really the point of this presentation is bringing it in, bringing OpenZiti and zero trust to the edge, right? And we that's really kind of our sales pitch, if you will. It's our pitch to the listeners of this presentation. It's you need zero trust at the edge. It's not just a
Yeah.
enterprise resource. And so I'm just going to advance the slide again. And this is really what caught your attention from me. I was socializing an idea that I call CRAV-ZT. So CRAV means contact in Hebrew, and so CRAV-ZT is full contact zero trust, and it's an approach to zero trust that focuses on real, practical, real world skills via the application of Krav Maga self-defense principles. And so, if anyone's not familiar, there's this Israeli self-defense system called Krav Maga, and it's and once again the Krav means contact in that phrase, and then Maga means let's see if I can remember. Um, I'm struggling to remember, but the Krav Maga is the self-defense system, and the self-defense system has these tenets and these principles, and I thought they were very, very applicable to zero trust. And the tenets that I kind of took from Krav Maga's Wikipedia website and brought it over to zero trust are: be aggressive but smart in your problem solving, be vigilant in identifying and addressing challenges, be proactive based on your current weaknesses or vulnerabilities. React quickly when you have to. Be tool agnostic, right? That speaks volumes, right? It's be tool agnostic. Invoke precision when executing tasks. Employ simple and repeatable techniques. Include situational awareness in all aspects of your practice. I mean, situational awareness just for any cyber program is just of the utmost importance, right? And then understand the impact of stress on planning and response. And so this is how we got connected, Philip. I mean, I remember you kind of reaching out to me because I posted this, and and that started our relationship and our friendship. Do you recall anything that you wanted to bring up about CrowdZT, or is there anything there?
I think the key thing for me was that other people were buying into the vision and the ideas which I'd had for at least about 3 years at that time, and has only continued talking to people, walking through problems, understanding where things don't apply. I think is the most useful thing from conferences and talking and interacting with people. So I just really appreciate the idea sharing and problem solving that we can do together with other people.
Oh, I love that. It's the core of open source, right? If you will,
Yes.
right? Just continuing along, SUSE and Zero Trust. There is a bunch of Zero Trust work that has been done and projects that have been completed and are part of the SUSE solution. And those include our own new vector solution, which is a Katie's native container security platform with runtime protection, and it's specifically for Kubernetes. And then Istio, if you use Rancher Prime, you can get a supported version of Istio. And Istio is a service mesh for traffic management, security, and observability. And so one of the things I'm going to be talking about today is the network overlay. And I know Philip is pretty expert at kind of what the differences are between a service mesh and an overlay. But I find in my mental model, I often think of a network overlay as something quite similar to a service mesh. And so if everyone wants to start kind of germinating on that, I think that's a good idea. And then, of course, OpenZiti, the OpenZiti project, the Zero Trust Overlay Network for secure app connectivity. And this is produced by NetFoundry. It's the company that Philip works at. And just continuing on, I'm going to get into what is an overlay network and why do you need one, especially for the edge, right? So this is really my theory, my thesis. This is Philip's thesis that you need an overlay network for an edge deployment, an edge environment. And so what is an overlay? A ZD network is an overlay abstracting lower layers to simplify software design. Using zero trust principles, it lets developers and operators focus on connectivity anywhere without worrying about low-level networking. And so I feel the need, Philip, to introduce the ZRock application at this point, right? So this is a application that anyone can go to. It's similar to ngrok, right? So the ngrok, if anyone's familiar with this, it's a way to share your local port, your local website. And I could give a demo at the end if time permitting, but it gives you the ability to share a local port out to the internet and then have other people connect up to it. And it's primarily used for testing of applications or testing websites or you can really do a lot with it. You can do TCP, you can do HTTP, you can do all sorts of things with it. But the ZRock application is using the OpenZiti framework and the OpenZiti application development environments to provide this service. And so it's if you want to check out a very simplified example of OpenZiti, you can leverage ZRock, and it is providing this overlay system. And so once again, it's an abstraction on top of the typical networking system. So if you imagine an edge environment has a Wi-Fi network, and this OpenZiti network would sit on top of it, providing this network connectivity to all of the devices and egress and ingress, and it's all secured and it's all zero trust, right? I feel like that was my best attempt at trying to an overview. Philip, did you have anything you wanted to kind of?
I have a different way of saying it,
Mhm.
which is about 3 years ago. I was talking to my daughter, who still is a massive fan of Harry Potter, and she said, "Would you do?" And I was like, "Oh my God, how do I describe overlay networks to my 5-year-old at the time daughter?" Um, and we ended up using Harry Potter analogies, and so effectively, it is a invisibility cloak, which enables your applications to be invisible from the network. You literally cannot be found or scanned on the network like Harry Potter when he walks around with his little cloak on. And number two, the port key. So you can magically move packets from one location to another. The castle or the ground still exist, but you don't walk through the castle. You just magically appear from location to location. That is effectively what OpenZiti abstracts. It makes you invisible to the network, so you can't be attacked from the network, and it enables you to move or connect across networks without having to configure the underlying network constructs. And so provides that abstraction layer on zero trust principles.
Oh, well said. Perfectly said. Um, just gonna advance the slides. And so, we did feel that we needed to define the edge, right? And so SUSE defines the edge as a platform providing customers the ability to manage thousands of distributed edge devices, saving operating costs and improving an efficiency of IT operations. And so, your edge devices could be, at a retail outlet, they could be in manufacturing, they could be in healthcare, they could be in telecom. But, we're really kind of separates it from like typical enterprise IT is it's not housed in a data center. It's out in a warehouse. It's out in a manufacturing plant. It's out in a hospital. But there's once again this concept of thousands of devices. And what we're talking about is, letting the devices rely upon that pre-existing, underlying network, right? That Wi-Fi network, if you will, that was installed in that manufacturing facility or that hospital. And then what we're doing is we're talking about having an overlay network and a network that sits on top of that of that Wi-Fi network that provides secure, point to point, multi-point connections so that your application can traverse that Wi-Fi network and go out to the internet, back to a data center, or go, internally within that network and share data between devices and so forth. And it can do that in the secure, zero trusted way, right? That's really what's really kind of critical about what we're talking about with the edge. And I believe there's another infographic and that we have here. And I think what we're trying to articulate here is just that it's thousands of devices, all consuming this zero trust network for connectivity amongst themselves and back to a centralized like a data center or a centralized cloud location. And so it's full connectivity provided as an overlay network. Philip, did you have
Yeah,
any
I think
comments? Mhm.
yeah, I was going to say the key bit that really sticks out to me is as you look at this diagram, like the existing tools and framework that we know and love within the Kubernetes ecosystem that SUSE delivers, they're wonderful for providing each of those components to run the near edge, the far edge, the tiny edge, etc. But as we see on the diagram, there's lots of white space. And again, we'll go deeper into this later, but when we look at NuVector, when we look at Istio, they do not solve for the white space. That white space is VPNs and load balancers and firewall rules and DNS and all of this stuff. And OpenZiti does solve that. It provides that abstraction so that things can securely and privately connect anywhere, whether it's across the internet, kind of north-south, whether it's east-west within an environment, and to do it in a way which may be Kubernetes or Docker-based systems, but it also may be non-Docker or Kubernetes-based systems, particularly because when we come to the edge, we interact with legacy, the dirty word. And these may be systems that have existed for 10, 20, 30 years, and we can't just rip them out and replace them. We need to interact with them. And so that's required. And the other thing is that as we move from these wonderful, shiny cloud data centers to the edge, to the far edge, the tiny edge, we frequently are now talking around industrial use cases, OT use cases, environments where we have NERC SIP for grid and energy or 62443 for factories and critical infrastructure environments. And they have very, very different security and operational requirements, which we need to solve. And traditionally, people air gap, or they talk about Purdue, or they're using VPNs, they use OpenVPN, IPsec, blah, blah, blah. And it works, but everyone hates them. And increasingly these worlds coming together, what's called IT-OT integration. But that requires solving these problems and doing it in a way that aligns to those frameworks and standards. And so that is exactly the problem that OpenZiti and NetFoundry look to solve so that we can securely connect everything, the edge, near edge, tiny edge, anything, anywhere.
Anything, anywhere. I love it. And this list is just speaks volumes to me. It's the VPN connectivity. It's the complicated firewall rules that are necessary. It's the layer 4 load balancers. It's the private APNs, the ACLs, the VLANs, the public DNS inbound imports, and more. It's all of that stuff is provided to the edge as this overlay system via OpenZiti. That's really the one of the biggest takeaways. And so, once again, we're talking about using NetFoundry and OpenZiti to abstract out the underlying network complexity to focus on connectivity anywhere using zero trust principles. And I think it's now's a good time to kind of bring up that that OpenZiti, due to its open source nature, I assume, it allows for you to use it in multiple different environments. My demo today is being run on SL Micro, right? But you can use OpenZiti and the overlay networking system and the zero trust approach in SUSE Rancher. You can also use application development SDKs to write your application, install them on SL Micro, and then they can communicate with the OpenZiti network, with the OpenZiti router, the OpenZiti tunnels, or the different various components. And you're just running an application in a container in SLE Micro. It's like, according to me, Philip, it's magic. I know
Yeah,
you're talking about the Harry
that's why I
Potter.
wrote the blog.
I mean, just
Yeah, 100%. And I think this also speaks to the, again, when we come to the near edge, the tiny edge, we're talking about compute environments that they're not designed for big chunky pieces of compute that we run in the cloud. We have people that use our technology together with drones. They use our technology together with industrial firewalls. I think in the military they call it SWAPC. So things that are very, very low power, compute, footprint, space, etc. The overlay itself, we literally have a military use case where they're deploying it on a Raspberry Pi 4, just like in the middle of nowhere, on a tactical military network or something. So whether it's the overlay or the edge, it's all designed to run incredibly constrained, but also big if we've got the resources.
right, yeah, and I think I think that's a testament to the OpenZT project. It can run essentially anywhere. And give you that layer of abstraction so that you can have secure networking no matter where you're running it. That's really critical to kind of understand. But I think you got to tell. I think one of the things that I'm most excited about is the SDKs. Right, you can run on SLE Micro. You can run an application in a container that has been written with the OpenZT's SDKs, and it's in a handful of languages, right? It's like 8 or 9 various languages, Go and C and Java, and all these different languages, and then you take advantage of it just from an application, layer 7, if you will, and you have this ability to use the overlay network. It's really stupendous. But without further ado, I just wanted to define what SLE Micro is, SL Micro is. It's a scalable, predictable, immutable OS built for edge use cases. That immutable word is kind of an odd one, if you will, but what it refers to is you can't mutate it, right? It's a secure OS that you cannot mutate. And so it's this little platform that's designed for the edge for you to run your applications or run, in my demo, I'm running the containers that OpenZiti provides for the router, for the tunnel, for the ZAC, which is the access controller. I'm running them all on a SLE Micro, SL Micro instances, excuse me. And I'm doing it with Podman. It's trivial. It's trivial to get this set up. It's trivial to use, uh, um, given the amount of work that's gone into all of these different projects. And we're very much standing on the shoulders of giants. We're standing on the shoulders of SL Micro. We're standing on the shoulders of OpenZiti. We're standing on the shoulders of the OpenZiti project and the SDKs that it's made available, and all the fine work that Philip and his colleagues have done. And just to tie it off with SL Micro, it's reliable automated updates and recovery. It's a tiny footprint, right? I'm running it in a very, very tiny VM on my laboratory machine, and apps and services are containerized. And that's really one of the critical things about it. The benefits are more flexibility in the life cycle. There's lower maintenance efforts. It's lighter co-instability constraints, less backporting, Linux for containerized applications with enterprise grade support. And so, from this diagram, I just want to call your attention to, in a regular Linux, there's thousands of packages, in our distro, it's all RPM based, and they're all co-installable. They have the same life cycles. And then with SLE Micro running these pods via Podman, you have this ability to have independent life cycles. So the OpenZiti software, as it comes out and it's available on hub.docker.com, you can upgrade and downgrade, and you can make this available to your fleet of SL Micro instances that are deployed in the field, right? And once again, it's that small footprint and the immutable OS are really tremendous benefits for the edge and leveraging the OpenZiti suite, right? So, it's kind of a combination. They marry very, very, very closely and very, very well together. And so just finally, just to drive the point home, we have that tiny footprint in its enterprise grade. We have mission criticality. Our goal is to deliver zero maintenance infrastructure designed for the long-term support. So you can deploy it and forget it, right? And that's a testament to the overarching designs that have gone into both OpenZiti, via Foundry, and SUSE. And then it's made for developers and it's perfect for containers. And so without further ado, we're going to dig into what OpenZiti is. I'm going to hand it over to Philip for this part of the presentation.
Thanks, Thomas. I'm going to go fairly quickly. But essentially, it's an overlay network. It is the edge, which, as you allude to, is SDKs, it's tunnelers which deploy on all operating systems, or it's even virtual appliances. And they go at source and destination and act as points of ingress or egress, where we consume strong identity based upon X509 or OICD or other PKI-based systems. It could be hardware roots of trust or TPMs from our edge devices. And they do authentication authorization before connectivity. And then once you're authorized and authenticated, they build outbound connections into the data plane to bridge together that connectivity. So you're able to move packets in an abstracted fashion. If we go on to the next slide, we can see that effectively we're doing double encryption. We're doing mutual TLS between every single hop, and then we're doing end-to-end encryption between the source and destination. And this is built to be crypto agile. So if someone comes on and says, "Hey, I need quantum," no problem. Swap a quantum cyber in there, and we're all happy. This ensures that we can provide very private, obfuscated connectivity without anyone able to intercept the data. The data is only readable between the original source and the final destination. And although this looks like one tunnel, we're actually separately encrypting and tunneling every single service so that you can deliver high performance and reliability with the least latency for every single application, which I think is very applicable to distributed edge and IoT use cases where we have lots of potential different routes and complicated relationships between applications and resources. If we go on to the next slide, then we can see what it looks like before and after. We're moving to trust and identity rather than IP addresses, where we're connecting apps rather than networks, where we're being invisible rather than having public IPs, where we are replacing VPNs, where we have the ability to build this directly into products rather than bolting products on after the fact. Jen Eastley, the former boss of CISA, said last year, we don't need more security products. We need more secure products. OpenZiti and NetFoundry does both. We can give you a more secure product, or we can help make your products more secure. And if we go on to the next slide, we'll quickly see, again, with the... I like to put an asterisk next to the replace because the abstraction layer is very brownfield compatible. We have people literally taking the technology and putting it into factories and other very legacy environments. And that enables you to maybe retire your complicated SD-WAN or your VPNs or your network access control or your complicated firewalls. Maybe you don't. Maybe you continue to use them. As you build abstraction layers, you can decide if you want to simplify what's below that abstraction layer. That's your choice. We give you that option, but it very much does help us to abstract away underlying complexity. And oh yeah, service mesh topic. it's because it comes up so often. And literally, this was a response I wrote last week to someone asking on our open source community. Because as you alluded to, there are, as ideas, there's a lot of similarities, but there's strong differences. Most service mesh is open by default. OpenZiti is not. It is closed by default. Most service mesh operates connecting Kubernetes and really focuses on east-west within the cluster. OpenZiti can do east, west, north, south. It can do Kubernetes. It can do non-Kubernetes. It can connect anything, anywhere. And it very much comes from the background of doing connections which assume something across the wide area network, which is why we built it also to replace VPNs and load balancers and other network infrastructures. So in fact, I know people who say to me, why would I need a service mesh? I'm using OpenZiti. I know people that go, of course I'm using my service mesh, Istio, whatever, together with OpenZiti because they both are different tools for different purposes. And so based upon what your needs are, what your requirements are, we can help people to understand exactly what solves which and how it can help you within your organization. I think that's the end of.
Yeah, this is the summary of the demo. Yeah. Yeah, so I think in the interest of time, I'm just gonna jump into the demo real quick and just fly through it. Philip, if that makes sense.
Yeah, please.
And so I just wanted to bring up a diagram of the demo first. And this diagram is kind of just tries to articulate that I have this laboratory environment and it's running SLE Micro on 3 VMs, right? And then underneath each of these, I'm running a router, and then I'm running a ZD controller and OpenZiti access controller, and then a web server on port 8000. And so what I'm going to do is I'm going to show that I have the OpenZiti network working between my lab and my laptop, my personal laptop. But once again, we have 3 web servers. They're running on 3 Micro instances, and OpenZiti is running an OpenZiti tunnel on 2 of the instances, and then it's running the router on one. And so it's very simplified installation. If I go in my web browser to web01.zd.8080, we can see that that's working. And then if I go to web02, we can see that we're hitting the second SLE Micro web 02, and this is web 03. Very similarly, I'm just going to go to web 03. We can see that we have routing all kind of working within the network, and it's a zero trusted network with mutual TLS and now everything that we just went over. And just to show you that there is a console, I'm going to go to, I have port forwarding set up, so I'm going to localhost 1408. And so we have a dashboard, and we can see geographic data of the network, and we can instrument it so that we know where the various routers and tunnels and everything are. We have various identities, right? We have my 2 tunnels, and we have the router. We have various recipes. I created 2 services, web 01 and web 02, and we can see that here. And the service definition allows for the connectivity to those web servers. We have various configuration. There's a configs set up for web 01 and web 02, and there's an intercept config set up for it, and you get the JSON here that you can use, and you can leverage with an API call to instrument and communicate and coordinate and configure and manage the various configs. We have policies, and these are the bind policies and the dial policies for each of my 2 instances. And then once again, we have the routers and router 1 and tunnel 01 and tunnel 02. And this configuration is what makes that networking work between my laptop and the various web servers running on SLE Micro with a tunnel in OpenZiti. And that's about it. I just wanted to say a huge thank you to Philip for doing this with me. It's been a tremendous pleasure, and it's been a very enjoyable process, and it's great to know you, and you're always someone I can rely on, and I really appreciate that, Philip.
Sorry, you're dealing with a mute. It's been a pleasure. Kids in the background, I'm sure everyone knows that problem. Likewise, Tom, it's always been a pleasure. I love chatting around open source and zero trust.
Well, thank you again. And thank you to all the listeners of this particular tutorial session. And if you have any questions, you're free to reach out to me or Philip via LinkedIn, and we're here to help. We're here to help coach you in any way, coach you with a K in any way that we can around your zero trust journey and your edge journey.